Now I'm going to apply the reasoning that I have up on the previous blackboard here. Namely, I need to get the volume of this chunk. And the way I'm going to get the volume of this chunk is by figuring out its thickness and its area, its cross-sectional area. And that's not too difficult to do. If this height, so this height is what we usually call y. Y is usually a function of x. It's varying. This particular distance is y. Then the area of the face is easy to calculate because it's a circle, or a disk, if you like, with this radius. So its area is pi y squared. So that's, if you like, the one of the dimensions. And then the thickness is dx. So the incremental volume is this. So this is the method of disks. And this is the integrand. Now there's one peculiar thing about this formula, and there are more peculiar things about this formula, but there's one peculiar thing that you should notice immediately, which is that I'm integrating with respect to x, and I haven't yet told you what y is. Oh, that will depend on what function y equals f of x I use. So we have to plug that in eventually. If we're actually going to calculate something, we're going to have to figure that out. There's another very important point, which is that in order to get a definite integral, something I haven't mentioned, we're going to have to figure out where we're starting and where we're ending the picture, which is something we dealt with last time in 2D pictures.